is 5,625. And 1,000 T's at 12 cents each. It's 12. No, I didn't do that right. 1,000 times 0.12. I just did times 12. No, I did it again. 1,000 times 0.12 equals 120. So, yeah. Yep. Yeah, so that's nominal right here, yeah.
Nominal is 8,495.
They're actually asking what is the CPI for each year, which you actually, if you calculate the CPI for each year, right? What would you need for that to calculate
The CPI, you would take this divided by this times 100 if you're making this your base year.
Mm-hmm.
And then you would take this divided by this
Mm-hmm.
to find times 100
Yeah.
to figure that out.
So that's how you would do it if these were equal quantities, remember? But they're buying different
that's
amounts in
right,
this
that's right.
problem. That's what's difficult. So what you need to do here is you need to take the prices they're paying for them each year and multiply them by the, so we actually have a nominal here that's wrong, right?
Okay.
Because what we want it to do is get that same basket of goods, right? Because this is a higher quantity, but we want it to be the same as that. So we could do the math again though, right here, right? Where you do,
Okay.
so this is good because this is a problem you might see here. So if you say in 2011 they bought, it doesn't matter how many, you just want to do it by the
You
same
wanna do it by
amount
the
that they did
original
before.
amount
Yeah,
with the new price.
new price, right.
Okay.
So now we'll do the math again at 1,000 at $2.50 each, right?
Okay, so
So
that's
that's
2,500.
Right. And then they had let's see, 100 clubs, and then the new price is $75 each.
Okay, so that's
7,000.
7,500.
Right. And then
12
1,000,
cents.
let's see. It's 10, yeah, it's 12 cents now, and it was 500 T's back then. So
That's
that's
500?
half, yeah, so,
Okay.
right.
And
So-
12, so that's 600?
It's going to be, yeah, let me just do that just to be sure. I think that's, it's going to be actually, let's see, 500 times 1.12, 60, sorry.
60.
Yeah, so.
So it's 10,000.
Right, so that's
60,
nominal.
and that's
Yeah. Right now that makes sense, right? Because that's
Yeah.
saying the new prices with the same basket of goods. Does that make sense why that was? Because if you compared them before, you were paying for a different amount, so it wasn't really
Okay.
comparable.
so
But now you're comparing, so that's saying for the same amount of goods that cost 7,000 then, now that same amount of goods costs 10,000 today, right?
wouldn't that be over in real?
No, so now, sorry.
Oh, you're fine.
So you had it exactly right how to find the CPI for this year.
Okay,
So now
so
use these
take-
and see.
This divided by that,
Mm-hmm.
10,060 divided by 7050 equal, wait, 10,060 divided by 7050. 1.4269, so 1.43.
So times 100, right?
Oh,
Remember?
yeah.
Yep.
Times 100. 142.7. Okay.
Yeah. So they actually in this question, all it really asks for is the CPI, and then it asks you to say how much inflation is going on, right?
So
you
it's
could just
42.5%
Right.
inflation,
yeah,
which
yes,
is
that's a lot.
insanely high.
Yeah, that's not normal. So, but so if you wanted to convert it into real though, right? You could say, okay, if we're going to do it in $2011, right? That's going to be 10,000. So like, if you just say that's 10,000, so we're going to say in 2011 dollars, right? And then define the real for how much it was before.
You would do the,
remember?
let's see,
Yeah, so
it's not the old minus the new divided by the new.
That's percentage change. That's how you would calculate it. So this is easy to say that's 42% because that's 100. But if it's not 100, then you have to use that formula that you're talking about to find the percentage change. But
just a second. I'm not remembering.
Yeah, so remember we took this CPI divided by that CPI, and then we times it by that price. Remember, to get it into our dollars today.
So
right?
we take 142.5
divided by 100. Right.
Divided by 100. And then we take that
multiply
times
it by,
the first nominal, the base nominal, times 7050.
Did we do that right?
See, I'm wondering if
that number
wasn't 0.5.
I don't think that would change that. Well, because the real should change still, though. Let me see if. Okay, wait. How do we do that? We did. So you did 142.5 divided by 100 times 7050. Is that what you did? And then that's what you got.
I think so. Let me try it again.
Yeah.
142.5 divided by 100.
Oh, that would make sense.
Times.
Sorry.
7050.
I think you said 0.7 actually right here.
Yeah.
And then you wrote 0.5.
Okay.
Yeah, you're right. Yeah, because these should equal each other, right? Because we're saying this is the same amount of goods. Right?
Okay, so these should be the same.
Right, once you adjust for inflation. Because you've already adjusted for the same, you've already taken it so that it's only the same amount of products. Now you're adjusting for inflation and you should get those to be the same right there.
Okay.
Yeah. Yeah, so in this problem it didn't really ask about this anyways. It was only asking about the CPI and the inflation rate. Which,
Okay, so to figure out the inflation rate, I would take this minus this divided by this. Times 100 to get the percentage of inflation.
Right.
Okay.
Because, and so like that, the reason that equation is handy is because like maybe in 2012, right, you have one that's 158.2, right? And then it's saying, what was the inflation in this year right here, right? So now you can't just do it in your head because you don't have 100, right? So that's when you would do. I
would do 158.2 minus 142.7 divided by 142.7 times 100, and I've got a 10.9, 10.86
percent increase.
Inflation rate. Between those two.
Yeah, inflation rate is a percentage increase. It's the exact same thing, right?
Okay.
And that's the equation to find percentage increase in any mathematics, in any problem. In this case, in this context, that is the inflation rate. So that's why you use that formula.
Okay.
Yeah, so that's right. Perfect.
That makes sense.
Cool. Then, I think that's the last one. Oh yeah, here it has them solved. So you can go over them again. Or wait, no. Is that?
Let's see what that is. We worked on 4.
But here it says solved problems, but I guess they're different problems here.
No, it's the same. It's just
same?
walking you through all the steps.
Oh, yeah, you're right. Just the 5 for 4 and 5. You're 5.
So it does equal up being 42.7.
Yeah, which is pretty close to it. Oh, yeah, that's exactly what we decided. But yeah, so if you wanted to walk through that problem again and refresh it by yourself, I think that's always the best. It's like when I'm in class and I get a problem and I figure it out in class, it's easy to understand when someone's telling it to me, the teacher's explaining. But then I have to go home and I'll just take just this and try and see if I can solve the problem again on my own, right? And then if you can't, you can refer to this and say like, oh yeah, because that'll be like, you'll remember, you'll be like, oh yeah, I know why we did that. But it's good to just go over that again on your own. But I don't know if you wanted to go over anything else.
I don't know.
You have 5 more minutes.
Okay.
If you wanted to. You're welcome to stay. If not, you don't have to stay.
No, that's fine. Okay, so I guess I can. We're having a test where he's going to let us come in with just a card that has equations on it or whatever, but I can go through and find those.
Yeah, so I guess what I would say would be, so your new minus old, right? Let's write all the equations off that we, at least for this chapter that we've gone over, right? So we have your new minus old divided by old, right?
Mm-hmm.
And what did that give you?
That was to figure the percentage increase.
Percentage change.
Yeah.
Which in this chapter we said that was the same as the inflation rate, right?
Yeah.
Oh, sorry. So yeah. Also, don't forget times 100.
Yes.
Because otherwise, yeah. And then there was also this. Remember, there was CPI. I'm going to do CPI of like year 2 minus the CPI of year 1. CPI of year 1, right? Divided by, did we divide it? No, we did, sorry. We did CPI 2 divided by the CPI of year 1, right? And then we multiply that by the price of year, let's see, I guess that's using this equation. I mean, write it up whichever way makes most sense to you, right, on the card, so that you can use it right here. But here it's saying, so price level today, price level earlier time, and then times that by the price level of that earlier time.
Okay.
And that's going to give you, what does that give you then?
That's going to give you current value? Like how?
Yeah.
I'm trying to think of the word for it.
It's the value of whatever you were looking at in that previous year in today's dollars.
Yeah.
Right? So you can compare, so now what you would be able to do is you could compare like price 1, you could compare that to price 2. And then you could say if it's going up or down or...
So like if my dad tells me, I made $1 an hour when I was in college and I'm making $10 an hour now, and I can compare, okay, am I making more comparative to him?
Exactly, yeah. So what that would do is like if you were doing that in this example, right, then you would say like, okay, so this is going to be your price index of your dad's time, and this is the price index of your time, and this is what your dad was making before. And then it's going to give you some number that was what your dad was making in today's dollars before, right?
Okay. Now, will they always supply me with the CPI, or do I have to figure it out on my own?
You might have to figure it out sometimes too, which if you had to figure it out, then that was when they would give you like that example we did with the golf balls and all that stuff.
Okay.
It's like you figured out the CPI then. Now with that question, they could say, okay, if they're buying this many, then or you know what I mean? Then they could use that to do a question where you have to use this equation. Okay. But so.
Okay.
So to find that other one though, remember that other one was when we took the basket of goods, right? The basket of goods, and we times it by like some year of prices, right?
Yeah.
We're going to say times year 1 prices. Dollars.
Was it times or divided by?
Sorry. Well, to start out with, so that, I guess, that one, there's not really a specific equation, but it's, I'm trying to think if they had a good example. Yeah, this is what they're doing in this box here, is what we did with the golf balls, right?
Yeah, to find the CPI, that divided by that times 100 equals that divided by that times 100.
Right, so what they're doing here, though, is they're taking the same quantity, right? So they keep the quantity constant, and they're multiplying the quantity by this year's price, and they get a total price here, right? And then they take the quantity and they times it by this price, and then they get another price here, right? That way they can add up. This is one basket, and this is the same basket just in that year's prices, and that's in that year's prices. Right? That's what we had to do with the golf balls, right? Because the 2 baskets were different sizes, so we had to say, okay, we're going to take the first year's basket, and we're going to take those quantities. So we took all those quantities, and if we were going to make a table like this, we would have put a table right here with like, I don't know, whatever it was, 1,000 golf balls, 500 clubs, and 10, and then we would multiply that by the price for that current year, and we got that total, and then we multiplied it by the price of that future year, then we got a total right there. Yeah.
So they're really just throwing you off when they say they bought this many more than they did before. That doesn't matter for CPI.
Right.
It might matter for, okay, supply and demand and things like that. Different. But for inflation and CPI, the new amount that they're buying does not matter.
Right. And that's, I mean, it tricked us, right? Because at first we multiplied by those new, and then we did that and we got some weird number. So you can kind of say like, okay, there's something not right there, and then you realize, oh yeah, it's because this basket's different, so I can't really, you know what I mean? Obviously it's going to cost more because there's more, you're buying more, but we just want to know what the inflation rate was. So that's why we just try and use one quantity. And it doesn't matter, we could have used the second year's quantity and we could have multiplied it by the first year's prices.
We just
need the same
quantity both times
right.
to figure it out.